Hello geometry students, welcome to another edition of your notes titled 12-6 Notes on Tangent Lines in Circles. Okay, so we know what a tangent line is. We've seen that before. We should know that a tangent line intersects a circle at exactly one point. Okay, the first part of these notes deal with, as we can see, tangent lines with a radius. There's some relationship that goes on with those. All right, so here I have a circle called the circle O. And I have line T, this is my tangent line. They intersect at point P. Point P is called the point of tangency. Okay? What I know about the relationship here is that they make a right angle. Anytime you have a radius and a tangent line, they make a right angle. So the tangent is perpendicular to the radius. Okay? Well, what can happen with that is I can connect another line out here that connects my radius to any point on that tangent line going in a different direction, and it makes a right triangle. Okay, and with the right triangle, I can use Pythagorean Theorem. I can solve for angles of a triangle. Let's say, for example, to give us a central angle here, and I can find the third angle by using 180 in a triangle. The angles equal 180, or any such thing. So example one, let's look at that. Take a minute, copy this question down. It wants to find the length of just this piece outside of my circle, okay? And if I have a radius here is 10, and a tangent line touching exactly one point, they make a right angle, so I have that right triangle, and I can use Pythagorean Theorem. Pythagorean Theorem will be used to solve for this whole side here, we'll call it side C. So to solve Pythagorean Theorem, I've got 10 squared plus 10.5 squared is going to be equal to C squared. I know 10 squared is 100. I can use my calculator. 10.5 squared gets me 110.25. Then add those together. So I have 210.25 equals C squared. And the square root of both sides will leave me exactly 14.5 is equal to C. So 14.5 here is the whole entire side C. Well, they just want this piece here, so I got to try and find that. As I've said before, the radius in a circle is exact same as any other radius in that same circle. So if this is 10, we can see the radius right here would also be 10. So to find my angle in question mark, I'm going to take the 14.5 I found for all of my triangle, subtract the 10, and that leaves me with 4.5 for the length of question mark right there. All right? Next piece we know for tangents is I can have two tangent lines coming together intersecting at one point outside of the circle. So here I have a circle. Into the circle I've got some radii drawn in, I even have a chord, but that is not important in this instance. What I have are two tangent lines intersecting at one point. Okay? What's special about that is those two tangent lines will be the exact same. They'll be congruent. So I'm going to call this one tangent 1, I'm going to call this one tangent 2, and in this case tangent 1 is the exact same as tangent 2. Alright? So that's going to be important anytime we see that together. So here's an example. Example 2, here I've got a circle, two tangent lines coming out, all right, and I've got 3x plus 6 and 4x minus 3 representing each one of those tangent lines. They're going to be equal to each other, they're congruent, so I can just simply set them congruent to each other. 4x minus 3 is equal to 3x plus 6. Solve for x, so I subtract 3x from both sides. I'm left with x minus 3 equals 6. Add 3 to both sides. So I have x equals 9. Okay? And that's it about tangent lines and circles. Again, I've got them being perpendicular to each other, and I can use that to distinguish angles and solve for angles. I went through my examples. Two tangent lines are equal to each other. Do not forget your WSQ. Have a great day.